So if we were together, we'd be working on this super cool mastery assessments called the Baker's Dozen. And so it's kind of the 13 skills that for sure used to show up on the AP test. So as we do each problem, let's think about like why they were assessing us. Okay, so the first one is a limit. So I think if I scan down, that is topic 3. Okay, so sometimes you'll use pre-calc skills to check a limit. The new thing we learned was L'Hopital, so let's see if we could use L'Hopitals. So the big idea is if you plugged in 2, you would get f of 2 minus 9 over 2 minus 2, but f of 2 is 9, and so you're like, oh, this is 0 over 0, so we can use L'Hopital's rule. Okay, L'Hopital says that limit is equivalent to a new limit where you take the derivative of the numerator over the derivative of the denominator. So the derivative of the numerator is f prime of x, and the derivative of the denominator is just 1. And the goal is that hopefully if you plug in 2, you can get just a function you can evaluate. So let's see. So we need to find f prime. So f prime of x is 3x squared plus 1, which means f prime of 2 is 3 times 4 plus 1, which is 13. So I can actually evaluate this now by 2 algebra skills. I can put this into the function. So this is 13 over 1, which is 13. Okay, let's look at the next one. Oh, that's our favorite. That is the second fundamental theorem of calculus. So that is 9, which tells you how to take the derivative of an accumulation function. Okay, so we know how to do that. So h prime of x is 1. The derivative of that is 1. This is kind of the most basic form. So the derivative of that form is literally just the integrand evaluated at this variable. So if I want to do h prime of 2, it's 1 plus f of 2. But 1 plus f of 2 is 9. And so it answers 10. Okay. Oh, now we got a particle motion. That's topic 10. Okay, so let's see what we have. Okay, so we talked about this a couple times and people were still having a tough time with this. You have to check velocity and acceleration. And if they're the same sign, if they're both plus or they're both minus, that means we're going to speed up. If they're opposite signs, they're going to slow down. Okay, so let's see. So we want v of 2, which they told me is the same as f, which is f of 2, which we already know is 9. And what's the attribute that's important about 9? 9 is bigger than 0. Okay, now if we do acceleration at 2, which is v prime of 2, which is f prime of 2, which I think we already counted, that's 13. A lot of times in the free response, you use things you calculated earlier. You know that's bigger than 0. Okay, I'll make a little space here. Therefore, speeding up. How come? Because v of 2 and a of 2 are both positive. Okay, let's look at the next one. Okay, so how do we evaluate a definite integral? You look at the integrand. You could, I think it's the bright pink one, but how do you evaluate that? I don't have a rule for G. I don't have a table for G. So you must have to use the fundamental theorem. Okay, so the fundamental theorem says you need the antiderivative for G prime. So if G prime is here, its antiderivative is G. So this would be the same as G of 29 minus G of 9. We did a lot of problems like this in our last in our integral mastery. And there must be some way to figure this out. They didn't tell us about G, but they told us about F. So they told us that F of 3 is 29. And they told us that F of 2 is 9. So that means that G of 29 is 3. And G of 9 is 2. So this is 3 minus 2, which is 1. Okay, then here's this skill that shows up sometimes, which was hard for you guys when we did it. This is, how do you find the derivative of an inverse function? Okay, so G prime of 9 would be 1 over F prime of something, but it's not going to be 9. It's going to be like the input you get to get 9. So since we know F of 2 is 9, this has to be 2, because these two things together make this point. And we already figured out F prime of 2 is 1 over 13. Whew.